A lot of awesome content for you guys. So yeah, I'm Ryan Feldman. I'm the Senior Software Development Manager over at LightGuide. We're based here in Michigan, in Wixom, so about 30, 40 minutes outside the city without traffic, and on a bad day, about an hour. And this is Will. He's our CTO. He's my boss, but
I'm just being shy today. You can talk. That's fine.
Okay, that's fine. So our presentation today is the future of XR and it being a spectrum of solutions. So at LightGuide, we do projector-based augmented reality, which if you've never heard of projector-based augmented reality, we'll have a lot of awesome stuff to show you. And if you have, then sit tight. You might still see some new things. But between Will and I, we've been in the XR field for couple decades between us. I mean, Will's been with the company a lot longer than I have. He's part of the founding group. And I've done stuff, everything spanning from projectors to immersive and mixed reality headsets. I really do like the headset space, but LightGuide has its own perks that we'll get to talk about and why I stick around. Next slide. It's not me.
Are you looking at the Zoom screen, maybe?
I don't even know how that is possible. I think there's a second screen someplace. Don't look behind the curtain. This is weird.
If you want to do an extended display mode, I can do that.
No, I just don't think I need it if I'm sharing my screen here. Yeah. Okay, that's fine.
Cool.
So as technology leaders in the space, Will and I have been privy to a lot of hands-on experience with a wide range of solutions, from projectors to headsets, like I mentioned. And we've seen a lot of stuff firsthand for what works and what doesn't, and understanding that technology is only as valuable as the people that are using it. So it's not good enough to have an awesome XR tech idea. You actually have to get people to use it, and that's usually the hard part. A lot of people call it pilot purgatory. So you start off with this awesome idea, you get a few people to use it, and then you just keep running into problems for that adoption. But at LightGuide, we have a lot of combined experience that has us deeply committed to innovation and balancing that always with user needs and the acceptance criteria for whatever it is that we're solutioning around. And that means more than just good ideas. It means rapid iteration. It means getting the technology in front of users as quickly as possible. At a hackathon, you'll be forced to do that. And having a deep understanding of who's going to use the technology, what their expectations are, the desired goals. We got Toby here in the audience. He's our lead UX, UI designer, and so Toby has to think about this a lot, but we're going to be doing most of the talking today, so I hope I don't mess that up for you, Toby. Okay, now you get to talk, Will.
Yay. So I'm Will. I'm CTO here at LightGuide. I've been at the company for a long time. Background, I went to Kettering University in Flint, electrical engineering. Did some study abroad in Germany. You can see some of the highlights there. I think the big takeaway from this is that I've been in a lot of different areas. And one thing that we at LightGuide are very serious about is we're not a technology-first company. We're an application-first company. And you can see from my resume, working with lasers, working with a lot of other technologies. We really try to bring that varied experience to the floor. And when I joined LightGuide, I was at Chrysler at that time, doing validation and new model launch work. And one thing that our founder, Paul Reisner, always tried to do, growing the company, was to bring people in with real-world manufacturing experience. We apply that in a way that works on a factory floor, and you'll see a lot more about that moving forward. So we'll talk a little bit more about my involvement at the company, but yeah, I think that's all I need to say. Go ahead, Ryan.
Okay. You had all those fun personal notes. You'll have to go back and read them. Will is a very interesting person. like you said, big background in a lot of different things. And I can say with confidence that although you may have only attended a few hackathons, you are a hacker, Will. 100%.
Yeah, well, any good engineer needs to tear stuff apart and, hack around, right? Very important.
And then for myself, I'm a graduate from Michigan State University. Don't boo me. I've been involved with RE and other, U of M organizations for a long time as well. Got mentors on both sides of the field. So, and I don't really follow the sports, but go green. Supplemented, so that experience along with game design and development, supplemented with a lot of free online courses. That's how I keep myself well equipped in industry, computer science background, game design and development. So if you imagine lots of real-time 3D engines and building immersive experiences around that. And so for my career highlights, it's working at several XR-related startups, working on several XR-related products that real people use. I've shipped a lot of things. And then getting to work with big tech companies and see kind of the other side of how some of this technology matures and then gets in the hands of consumers. And so if you're passionate about XR, feel like it's hard to not be a researcher. The field is changing so quickly. You have to stay up to date with the trends, the toolkits, things like that. And I find a lot of passion in kind of seeing how the space is evolving and trying to keep up with the times. And those are my personal notes if you find anything interesting in there. So a little bit more about LightGuide. We take manual processes and we project light on top of whatever that work area, workspace is in order to give people step-by-step work instructions and putting the guidance right on top of wherever the user's attention already is. So compared to other forms of XR, you might be looking through a little window, you might be looking through your phone, you might need to wear a special headset or goggles or be in some, even larger, more expensive setup. LightGuide tries to keep that simple by just working with the space that we have, using a projector to shine that light and give the guidance. LightGuide's also a platform, so we allow people to author, interact, and deploy projected-based AR workflows. And the architecture of that software suite itself is modeled very similar to PowerPoint or something you'd see in the Office suite to keep things accessible, easy to use. And then for our hackers, we also have an SDK and APIs to do custom, more bespoke solutions, extend LightGuide. And we've had tons of really cool projects ranging from media pipe integrations. If you're not familiar with that, it's a lightweight Google SDK for doing machine learning on local hardware, as well as people linking other software systems, other pieces of code into our larger platform and doing really amazing stuff there.
Yeah, you can use things like Node-RED, or some people run Python scripts out of our software. So, you can pretty much hook anything you want up to it. Mm-hmm.
Like I said before, we're based here in Michigan, Wixom, Michigan, but we also have an EU office in Prague in the Czech Republic and China.
Suzhou, yeah.
Suzhou?
Small office in China.
Mm-hmm.
But yeah, we have the three main offices where we have employees based to support global, mostly partners. We try to work with channel partners around the world because we do so much factory on-floor work that we need people who are nearby the factory to support those systems. So we have channel partners in places like Brazil or Italy or elsewhere that are doing that last mile support for our customers where there's hardware issues.
Mm-hmm. And so our mission at LightGuide is to empower people to build a brighter tomorrow. And what that means is creating a future where frontline workers reach their maximum potential through a different type of AI, augmented intelligence. So taking what you already know, the skills you already have, and trying to equip you with the right information, the right place, the right time in order for you to get that superhuman ability. For manufacturing, which is pretty much our bread and butter, we see 90% quality improvement for people that use our software. We see a 70% increase in training efficiency, and we also see a productivity increase as well. So LightGuide, we've been deploying it for well over a decade at this point, and really good proven track record of getting something out in the field that people use 24/7, that works, And it's not, something you're learning about in the classroom, speaking in theory. It's something that's out there today, and a pretty big footprint at that. So with that footprint, we're trusted by lots of companies. This is just a small subset of some of the ones that we work with. Some of the names might be familiar. Some of them may not be. Will, do you want to touch on any of the companies in particular? Or?
Yeah, I don't know why these ones in particular are chosen, but you'll see this on our website. And these are all good customers of ours. You see Ford is an automotive company. GE does quite a variety of things. L3 Harris is in the defense space. They do a lot of communications work. Magna is an automotive supplier. Flex makes electronics, Rivian's electric vehicles. Boeing, we all know. Stellantis is an automotive company. Caterpillar, I think we know. HP, the computer company, we work with them. And of course, Nissan and Medtronic in the medical space. One really interesting thing about this technology is it's not specific to any particular industry or application. We'll talk more about that later. And this is a small subset. It's only 12 names. We have hundreds of customers we've worked with over the years. So it's a very deep and broad list, but I think we have at least permission, which is not a very common thing, permission to broadcast their names as being customers of ours working with us. Whereas a lot of the companies that we're working with that are really interesting, really cool, we're not allowed to talk about working with them. So we chose them because they're on the website.
The NDAs are strong. Let's say that.
And you can imagine, because we're helping companies fix problems, like they have quality problems, productivity problems, they don't want their competitors or their customers sometimes to know that they're getting that help. So.
Word travels around though. So once we're working with one customer, sometimes people move around. Word of mouth is definitely a way that LightGuide gets told about. And we're here at U of M. We also have education setups at Purdue. We have education setups at Kettering.
University of Cincinnati, all over,
Yeah.
I can talk about this one.
Sure.
So like Ryan says, I've been at LightGuide for a long time. I joined in 2013 when there were 5 employees total, me, the founder, and 3 other folks. And it was very much a small kind of startup place at that point. The founder started the company actually back in 2005 and was experimenting with a lot of different guidance technologies, lasers, other technologies. And by the time I joined full-time in 2013, we had a working product. It was a projector-based software package that did just the basics of what LightGuide is today. So we brought on just a small number of people. We opened up a small office in Novi, about 2,000 square feet, and really started to scale the company. So that was just a short 11 years ago, I think, right? And you can see other various data points here. We started to bring on interns and full-time hires, and we started to incorporate more interesting technology into our stack. So in the very beginning, we could project, but we had no camera input. It wasn't very interactive. You had to have like a push button or a foot pedal or something to tell the system to move on to the next step and show more information. So starting in around 2016 or so, we started to do 3D vision cameras. So you guys know the Microsoft Kinect. Back then, it was the Microsoft Kinect, I think V2 at that time. After playing with the first generation, we launched the second generation as part of our product. And it's been many more generations after that between them and other brands. But that allowed us to have interactive work, where as you put your hand in different places, it would react to what you're doing, which made it much more powerful. We got a bigger office in Wixom, where we are now, about a 10,000 square foot office. We're renovating it right now, so if you ever get up to Wixom and you want to visit our office, in a few short weeks, we will have a brand new, beautiful demo zone with big industrial structures and lots of cool activity to look at. We started to get into some data tools. We'll talk more about that in a minute later on, and various integrations and technology add-ons and so on. So I won't take you through the full list here. We're going to talk about a lot of this later on in the presentation. But it's been a long climb, going from the very primitive early days to where we are today, and we have really big dreams, Ryan and I, for what we want to implement next that we are going to do as fast as we can.
Mm-hmm.
Yeah, these are some different products as we kind of categorize our technology. There's 4 main areas that you might bucket what we deliver to customers. The first one there, the work cell, that's your big custom system. And that can take a lot of different forms. Sometimes we will have 14 or more projectors, and we'll project onto very large objects, things like semi-truck trailers and fighter jet wings and those kinds of things. So super cool, big projects. We also have a much more modular workstation. It's just a bench that's like a 5 or 6 foot wide bench that rolls around on wheels, and it's all self-contained. That's nice because you can just, get it at your factory and immediately start to do things with it. But of course, it only works for things that are happening on a bench. So it wouldn't work for a fighter jet wing, for example. And then we have a very small Smart AI desktop. We have that here, and we actually have a lot of them here. So that those of you who are involved with the hackathon tomorrow morning can work with that and try out LightGuide and do things with it. And it's a really convenient form factor. It has a projector, it has a 3D camera, it has color cameras, it has a touchpad, it's got a touch screen. There's an Ethernet port and an extra video output if you want to use those. It has Wi-Fi. And we have, I think, some USB barcode scanners as well if you want to scan barcodes. And we can add more hardware too if you have other hardware. So that's a very convenient form factor. It's one plug to the wall, set it on a desktop, and you have that area to do your AR experience in. And then the final one, Spot Guide, is one of my favorites. If you go to concerts and you see those moving lights at like band concerts and football games and that kind of thing, these can be controlled by our software, and they can light up a bin where you need to pick apart or a location where you need to place a pallet of goods to guide people over very large areas with many, many lights. You can basically fill up a whole warehouse with these and just augment your entire warehouse. And then these all work together in concert too. They can communicate to each other and interact with each other and other hardware. So just a quick flyby. All right, finally we get to a video. Our technology, you really need to see videos to get your head around it. And you can see here, this is a very simple example that we did a lot of in the automotive tier 1 space, where a person needs to inspect the door panel. And so we have one projector and we have one 3D camera. That probably was a Microsoft Kinect of some type where we did that particular video. But you can see he's supposed to be looking at the various points on that door panel, and as he touches them, the 3D sensor sees his hand go to those zones, it turns them green, and it takes him through this inspection routine. So at the end of the day, the plant manager and the people running the plant can be very confident that that person is there, engaged, and not missing any points of the inspection. And you can see all the text there. There's a little bit of animation. There's some arrows. There's some white dots. That's all designed with your mouse. You just drag those over the parts of the door where you want to see them. And you can tie them to our 3D vision tools. It's all in our software package. So that when that tool goes through, it turns green and it moves on and it does the interaction. So a very simple, by our standards, application. It gets much more complicated, but it gives you an idea of the interaction and having something that guide somebody through a simple inspection application. This next one's also an inspection application, but it's a little more complicated.
1 second.
So this is in an actual car factory here in Michigan, and a person needs to inspect 10 different points around a vehicle. And they're looking for wire harnesses. There's a body harness of this vehicle that runs to the tail lights and to a couple ECUs and doors of the vehicle. If you don't put this harness in the right place at this point in the car's assembly, then later on, you're going to have a whole bunch of carpets and seats and other things that are covering up the harness, and to try to fix the problem would be very expensive. So it's really, really important that that harness is routed the right way at this point. And so what we have here are actually 6 different projectors covering about a 30-foot section of this moving assembly line. We've got 4 cameras, and as that car moves through this 30-foot zone, we're lighting up where a person needs to look for those different points on the wire harness. And you can see there's little hands that point where you need to be going. Those hands are moving with the vehicle. There's some other text on the floor that's telling you some information about what you're doing. And then it waits for a flashlight. You can go ahead and move it. It waits for a flashlight. And so it's interesting. We're using a flashlight. You're not touching the vehicle. The reason why is some of the points that they're inspecting, it would be not ergonomic. It would be uncomfortable to reach in there and actually physically touch some of those items. So by having a flashlight, you can just aim the beam at the thing that you're supposed to look at to prove that you looked at it. And then the camera sees that bright spot of the flashlight, buys off that you inspected it, and then you can move on. And if you don't inspect all 10 items on that vehicle, we can actually cause the line to stop so that it does not get any farther in production and they don't add any more value to the vehicle without knowing that all those components are in place. All of that data is stored and pushed up to their database that the plant has, so they have a record exactly when every single point was inspected. There's a timestamp on those records. and a lot of other really cool stuff to talk about. So that's another example. This one is quite a few examples, actually. We're doing a electric vehicle battery assembly. This is not the actual battery. This is a demo we made that very strongly resembles our customer's battery, but we couldn't use a live battery. But you can see, not only can it follow the vehicle around, so a little bit of that tracking. We don't have to do quite what Immersil's doing, where you have to take a bunch of pictures to get a full 3D map, but we can see the part and make sure we follow the part with our projection. And we guide you through an assembly routine. You can see there's some torquing happening here. The nut runner that actually tightens those torques, and that's a smart torque tool. So not only can it achieve a certain torque, it'll tell us exactly what torque it got. We can tell that tool to achieve a different torque. So if you're doing larger bolts, we can tell it, hey, go ahead and torque those harder. We can disable the tool. If you're not over the proper bolt, we'll make sure the tool does not even work. Well, that way you're guaranteed to torque the right nut in the right order, even if you try to not follow the lights, but it's easy enough to follow the lights. There's a lot of other interesting things going on here. I won't go into all of them, but you do get the idea of the step-by-step visual guidance. You just follow the lights. You know what to do, even with a minimal amount of training. We got a combination of smart tools, vision cameras, other sensors, barcode scanners that allow our platform to take you to the next step or to show you and react to what you're doing, not just the 3D sensor tools that you saw in that first video. But at the base of it all, it's just a very simple series of graphics that we project. Won't go into too much more of that, but for example, right here, the 3D sensor is looking for your hand to go in those zones, show that you had plugged in those connectors. This one's a little simpler. It's just showing where to put some items to build a wire harness. Applications like this are interesting because they're not necessarily ever the same. Sometimes you'll build a unique wire harness every single time. So in our authoring platform, we have to have the ability to pull in data from CAD and from spreadsheets and from other things so we know what the unique requirements are of the thing that we're building that time. So that presents a very interesting computer science problem sometimes when you have to make decisions about what order to show people things and how much information is the right amount of information to show them at a time and so on. And you can see there we're projecting some text, so they have to write out some labels, but you don't have to figure out what the label should say because the text is projected right next to them. This is an older application where we're building an automotive headliner using some hot glue guns, routing cables, showing people where to put tape to tape down those cables. We have a phone repair system here that's pretty interesting, so you can repair different phones. And depending on what's wrong with the phone, you'll get a different set of instructions. So you might tear the phone completely apart, repair and replace several different components. You might just replace a battery or a screen or a camera, or so on. And there's a lot of warnings here about things to be careful of as you're working on a phone. Got to be very careful with the lithium-ion batteries. They can spontaneously ignite if you don't treat them right. You can see there's some pretty small detail on this. This is just using the same sprout that we have here this weekend. Very small pixel sizes on the order of about 15 thousandths of an inch, so you can really get tiny details in there. So yeah, that's just a little flyby of what it can look like. I won't go through all of these because it can get pretty involved, but give you guys an idea. And then this shows a little bit of the what we call the vertical applications of our, I guess these are horizontal applications of our technology, right?
Different verticals.
Yeah.
Yeah.
Well, the verticals you'd be like automotive versus defense versus medical, but within any of those industries, you can do assembly and inspection, which is a lot of what we showed you. Training is the same thing, but much more granular for people who have never done it before. They can learn how to do something using the system. And there's different techniques for how you would build a workflow in a training mode versus an experienced operator mode. Part kitting and sequencing, I mentioned, Spot Guide's great for that. You can also use projectors to help pick a kit of a certain set of parts or pick parts in a sequence where, for example, on an automotive line, you might have several of one variant car come through plus a fourth variant that's different. You can put 3 of one part and a fourth of a different part in a box so that as you pull them out of the box for the vehicle, they are lined up in sequence with the vehicles coming down the line. So we do a lot of that. Maintenance remote support. You can see that's Ryan, and he's wearing a wearable. We don't just do projector-based work. We do some wearable work. And that's Ryan using a RealWear HMT1. And we'll talk about that a little bit in our presentation as well. We do some distributed manufacturing. During COVID, we were putting those sprouts in people's homes, and we were building face masks and other things, for home-based manufacturing, which is really interesting. And then finally, safety procedures, doing a little bit of interesting work in especially warehouses where we're helping people make sure they're parking in the right place and walking in the right areas and that kind of thing. So quite variety. You can take over, Ryan.
Okay. So when we're talking about XR solutions for the plant floor, that's very different than trying to build an XR solution for, let's say, Pokemon Go. I still play Pokemon Go. That's why I use it. It's not the only thing I know about. So on the plant floor, we have environmental hazards. We have safety hazards. We have interoperability concerns. There's lots of stuff on a plant floor that you probably don't have to worry about if you're just making a mobile app. And we also have to worry about security quite a bit. So LightGuide is capable, and in most times it's operating completely offline. So we don't want to have to worry about the internet going down and then a customer can't use our system. And so that's one of the requirements. But for safety, having technology that doesn't interfere with safety goggles. I don't know if you guys saw years ago the HoloLens. They relaunched a whole spin-off with Trimble to do a safe, hard hat version of that. And to have to spin off a whole new product just to get the technology adopted, that's a pretty big challenge. Environmental, you can have cold, hot, dirty. I don't know if you guys have ever been in 115-degree Arizona heat and you take out your phone to check Google Maps and it says it can't use Google Maps because your phone is too hot. Those are things that you have to be concerned about with extreme conditions. But it doesn't stop there. Here's where LightGuide really starts to shine. So nowadays, you got to worry about hygiene. I remember during COVID, there were whole companies that spun up around sanitized boxes that you can put your headset in, so that way the next person that comes in didn't have to wipe it down. It's already clean. Battery life. You have people that are using this technology 8 hours a day, 10 hours a day, and they can't wait if the headset dies. User prescription, you got glasses concerns. I don't know if you've ever tried to put on a VR headset with a pair of glasses. Not fun. Fall damage. Oops, I dropped my $3,000 headset on the ground, and now my cameras don't work.
Yeah, there's certain brands we won't use anymore because of that specific problem. Yeah.
Mm-hmm. Walking off your work area. You're running a demo, and it's a bunch of mobile phones that aren't tethered to your station, and someone just walks off with your phone. Impeding real world or view of real work. So I can't be looking through this little, screen if I'm also trying to do something on the other side over here.
And if you've worked with the HoloLens too, for example, we noticed that. Like we did some work with it, but anything that you're creating holograms for, you can't really see through it, it's in the way.
Wi-Fi connectivity, physical comfort, the list just continues. Doing things in industry is a lot harder than doing something, making an experience that someone uses once and then walks away from. Yeah. And this is actually a really good example of how XR technology can help accelerate things, and then there's a little Easter egg at the end. I don't know if you want to explain this one, Will.
Yeah, sure. Yeah. This is one of my favorite videos. It's a company called Upskill. They built a panel wiring application for a wind turbine factory. And you can notice on the left, that person is looking at a paper binder to get information about where each wire needs to go in the panel. And on the right, they have a wearable device. And they're using voice commands to tell the wearable device, take me next panel, or next wire, to see information about the same information, but on the wearable. So that alone, having that information in front of your face on a wearable versus having to look over at paper, saved them, over 30% of their time. So it's a pretty clear win from a value standpoint and a money standpoint. It's nice. But I ended up personally going to that plant and putting LightGuide in its place, and they did not, because they didn't end up using it. So why? Why would they not use it when they're saving 30% of the time? Well, if you go to the next slide, you'll see there were two main problems. The first main problem is that those wearables were not compatible with people's prescriptions and safety goggles. So they went through the exercise to say, okay, what does it take to have everybody's prescription on their wearables? They do this. And it became really, really expensive. And they do break and they do get dropped. And they have to get that person's prescription made again. And that really hurt that deployment a lot from a financial standpoint. But the second thing was the real clincher. You'll notice that's a kind of a large tractor-looking thing. It's a fork truck. Those things are huge because they're making wind turbines, and wind turbines have really, really big gears and really, really big components. And that giant red fork truck would drive right behind that person you saw in the video, like 20 times a day. And as it's driving by, you cannot make any voice commands, you can't hear anything, and they just can't work because the voice commands, that way of advancing it, which is never gonna work with the amount of noise that generates, plus other things that are happening in the plant. So yeah, it works great if it's in an isolated environment, but in that noisy factory floor, not so much. We put a projector over the panel. We use a 3D sensor, so every time they place a wire, the 3D sensor can see your hand, it shows you the next wire, and they were much happier with that solution. And there were no issue with voice commands, no issue with safety goggles, no issue with prescription glasses.
So it's not just me and Will that are passionate about XR for industry. Sure, some people here have heard of XRA, big XR organization that helps set standards, helps do research into the field. But if you look at the numbers, adoption rate is growing. 81% of manufacturing leaders believe that this is going to benefit the industry. Workforce challenges are addressed, so 77% are concerned about retaining workers, having the right guidance, trying to combat a skills shortage. And then I think this is the most important one, the positive impact. So when people use XR technology in industry in a way that makes sense for them, the results are overwhelmingly positive. It's a better experience for everyone overall. So 71% report positive worker experiences with XR, and they have optimism for the future of manufacturing. And so we'll talk about some of the things that XR can be used for in factories. You got expert remote support, Vuforia from PTC, and TeamViewer Pilot. Two very big companies, very well-known softwares, out-of-the-box, ready-to-go solutions for remote support. So LightGuide does not need to reinvent the wheel. If someone wants remote support, you can download one of those tools, or if you really want a LightGuide system to help you with that remote support, we can always talk. But if this is what you're looking for, there are tools that exist today. Similar for site planning and validation using XR. So this is a company called Theorem. I don't know if they're still around, but on the HoloLens and other holographic displays, you're able to set up your plant floor, kind of look around, make sure everything's going to fit together correctly. And I think you can even do some programming for your robots using the headset, which is pretty cool. When we're talking about safety training, immersive simulations, and collaboration, again, no shortage of tools that are out there. You have Pixel VR, which I think maybe they were here a year or two ago, or maybe that was a different company doing workplace safety training. You have Next Level VR or Next Level XR doing simulations for training, and then that's just a stock image of collaboration. There's many tools out there. My favorite is Shapes XR, if you guys have heard of that, but that's mainly used in like a VR headset. You can do it in mixed reality too. And all of those are really great applications for XR in industry today. So don't have to get too creative for any of those. We're running a little short on time, but we want to get you guys excited about kind of the simplicity of LightGuide, how it might apply to your hack. If you're considering using our technology, we'd love to have you do it. Will and I will be here as mentors throughout the weekend. And LightGuide and its pieces are pretty simple. So we have a computer, we have a projector, 3D sensor, and then any other pieces that you want to kind of tack on, whether that's a barcode scanner, other sensors, other display types. So you can show stuff from LightGuide on a monitor. We're not discriminating against that. And the application fundamentals, like I mentioned before, we tried to give it that Microsoft Office feel, inspired by PowerPoint. So what you see is what you get. And what that means is when you're programming in LightGuide, there are no surprises when you actually go to deploy it. It's what you were working on before. It's going to look the same. We can generate workflows, stuff that LightGuide consumes from XML. So your ChatGPT and others will, do just fine, helping fill in those gaps if you want to get crazy there. We have .NET drivers to automate that authoring, so we'd be happy to talk with you guys about, getting access to our SDK. And as far as the guidance goes, it really is as easy as insert your image, drag it over where you want it to appear, and then if you want that interactivity piece on top of it, you set up a little tool to recognize a hand or something went into that area, and then tying that back to the graphic. Workflows are sequential, so step 1, step 2, step 3, step 4, but we also support branching, so you can have step 1 go to step 5 and then go back up. Or get even more creative and have different workflows calling other experiences.
Subroutines, yeah.
Subroutines. And we also have a plethora of different protocol options. So if all of what I'm talking about is going over your head, that's fine. Just know that pretty much from any development environment, you'll be able to connect into LightGuide. I'm a Unity native. I've been developing in Unity for over a decade. And I can say with confidence, I've connected Unity with LightGuide and also lots of other things. So if you're curious about, how can I take this other skill set and maybe, get started with projector-based augmented reality, happy to help connect some of those dots. Here's an example or a list of I guess it's a dozen, but we have more things that we integrate with. For logistical reasons, we couldn't bring an example of each one of those for you guys to play with, but our office is, pretty close. If you want to, talk and you need something, we're happy to see what we can do. But we have collaborative robots, barcode scanners, RFID scanners. Those are like your little magnet, keyless entry, type things. Smart cameras, webcams, depth cameras. Those are your 3D cameras that can actually see the depth, like the Kinect and Orbeck and others. Sounded like you were going to interject.
Yeah, I was just saying, if you have spare hardware laying around, you want to try to connect it, bring it, try to do that. It's fun. It's more fun with hardware. Mm-hmm.
Smart torque tools, you guys saw that in some of the videos, but we also do Bluetooth gauges and calipers. So it really, there's whatever the spectrum is, we can tap into it somehow. It's just how hacky do we have to get? So I talked a lot about kind of the simplicity of the authoring experience, but this is a video showcasing the authoring of one of the demos that we have on our Sprout over there. So you can see the person typing in inspect part. As they're moving it on the screen, it's mirroring on the projected display. You can quickly just insert an image from your file system. You can also insert an image or video from a recording. LightGuide has a built-in snapshot feature, so if you don't have pictures of the thing that you want to do guidance on, no worries, you don't have to break out your phone, although you could. You can just take that top-down perspective, and you'll see in just a second how we kind of craft those part outlines. So you're able to draw on top of things, which is kind of cool. We've done research projects with students at Kettering for like magic wand drawing instead of having to use your mouse. So there's a lot that you could do. I want to see the part where we're taking that picture. Let's skip ahead. Oh, there we go. So here we're inserting a picture from file, something that we already put through and kind of took the background out. But rather than having to have a model that you're spatially tracking and something like that, we call this soft fixturing. We take an image of the thing, we scale it so that way it's the right perspective, and then we just tell you put it here. And that saves us a lot of time when people say, oh, I'm not able to reliably put this thing in the same place every time. We can say, no problem. Once the part arrives at station, we'll show you where it needs to go, and you don't need any special tooling to do that. Something you might have noticed and I don't like to talk about too much, but LightGuide's not as sexy as some of the other, things that you can do in XR. Sorry, Will. But it is simple, and that's the point. When we're trying to guide someone through a day-to-day task, they don't need, full swiping animations and 3 stars, good job. Although you can do that. LightGuide is more about giving people that practical benefit, and we do rely on minimalism a lot to do that. So we're not having walls of text, we're not having a bunch of flashy images. We want whatever we're projecting to be the thing that people focus on. And so that means sometimes making it less sexy. I mentioned the LightGuide connectivity, so we have a REST API. We also do TCP sockets for you hackers that are listening. You can connect LightGuide to new data sources. You can get and set variables within LightGuide. LightGuide organizes its data in variables. So is the part there? It's true or false. And so you can kind of force that if you need to. And you can also use our SDKs and APIs to pull data from LightGuide. And that's something we'll get into.
Right,
now.
I mentioned Node-RED already. If you use that, you could do all kinds of stuff. Play around with different protocols.
If you haven't heard of Node-RED, it's in the name. It's a node-based kind of programming language. So you can route inputs and outputs. You can manipulate data. It has a JavaScript backend. We're big fans of Node-RED. For the data storage and analysis, LightGuide in the background. So why would someone use LightGuide for something as simple as put the part here, inspect this thing? Well, on manual stations where people are doing work, oftentimes the last thing we think about is tracking that work. And LightGuide, by programming it, by putting it into the step-by-step workflow, we can passively collect that data in the background. And it's not Big Brother, making sure that everything is done right to a T or you're fired. It is for process improvement. It's for quality control. It's for making sure that people are doing their jobs. But it's also to give people insights into manual work that you otherwise would not get. Did the work get done? Yes or no? That's usually as deep as it goes. Did we hit our product throughput for today? Yes or no? But this allows you, LightGuide allows you to dive a little bit deeper and understand, even at the operator level, individual people, how are they performing? Does Ryan struggle on this particular step for some reason? Maybe I should go talk to Ryan about that. It's unlikely when people first start with LightGuide that they're thinking along those lines, but it's one of those implicit benefits you get from structuring your workflows, from putting it into LightGuide, and from having a system that's able to hold your hand through whatever that process is.
Yeah, this is an area I'm hoping somebody wants to play with this weekend because it's really, really powerful, and we, quite frankly, haven't explored it as much as we want to be. So, learning about how people are working and reacting to their performance, and it's just really, really cool. We have a lot of really cool use cases that we haven't explored yet, so good stuff there.
Okay, now for something that is sexy and cool. This is my favorite LightGuide demo. So I'm going to actually mute the audio. So what you might not know is that a really good bartender, an expert bartender, is able to do 3, 4, maybe 5 drinks from memory. So you got a packed bar, and you say, what do you want? And you're able to keep about 3, 4, 5 of those in random access memory at a given time. And that's for the best of the best. When you have drinks that have different, ingredients going into them, it gets more complicated. It's not 3, Shirley Temples. It's, something with a lot of ingredients. Well, what we decided to do was not only augment the bartending experience, but try to make it pleasant for whoever is on the other side of it. And this was showcased at a global food trade show. I don't know what was the name of it.
I think it was the National Restaurant Association, the NRA, but not the NRA you think of.
Yeah. So National Restaurant Association. And what we allow people to do is you don't need to be an expert in pouring drinks. You don't need to be an expert bartender. We'll hold your hand and make sure that every ingredient gets in there. Something that's not showcased here in this demo is Bluetooth pourers. So you actually don't have to, measure out your shot glass. You can just pour, and then when you get an ounce, it stops. Right. And LightGuide's able to tap into that to know, what ingredients were satisfied, did the right amount of ingredients go in, and instead of making, maybe 2 drinks or 1 drink if you're me at a time, I can't keep that much in memory, you're able to do all of them. And a lot of effort went into this demo. You can see we're, instead of like a normal tabletop, we have like a LCD screen and some glass on top. So we're not only able to project on the top, but we're also able to illuminate the bottom of the glasses, which is really cool. And yeah, it's just an awesome demo that is not related to manufacturing. So
it's a good opportunity to play with design too. You see the cherries and things rotating around. We had a lot of fun with that. So.
Mm-hmm. So thank you everyone for listening in. We do have some additional slides here at the end with case studies and other things that we can point to, but I'm sure for a lot of you, this is your first introduction to projector-based augmented reality. We're honored to be here and be talking to you guys, and we're really looking forward to the hack. We don't get to bring our technology out and show it and have access to students nearly as often as we'd like to. Even if you just want to play with it, we'd love to see your interest and answer some questions. And before you leave tonight, we have a Sprout here. You can play with it. It's really fun. Like that's one of my big takeaways is once you get to interact with the projections, it really is a very different XR experience compared to a headset. And we're all about accessibility here at LightGuide, so we want to hear your thoughts too. And yeah, I won't draw it out. Any questions? Yeah. Yeah. Do you need a microphone or? I'll repeat the question. Go ahead.
I'll just shut it out.
Yeah.
So I see the demo where you have like the worker do this scooter.
Mm-hmm.
Like, okay, so they make sure the boat is carried in. So when the boat is carried in, click turn green. And the same things apply for the shot table. Like you put in the water and then it says stop.
Mm-hmm.
I'm just wondering, how do you determine that bolt is screwed like perfectly? You determine by the time it's the time that is not hiding the lights, or how do you determine like that bolt is okay and then you turn it into green? And also for the shot table. Like every time people pour the water is not in the same speed. Sometimes people like pour really heavy, sometimes pour a little. Then how you determine that is the right amount? I'm really curious.
Yeah, so great question. I'll answer the torque one first. So with that one, we had a smart torque tool. So that's a very powerful, expensive torque tool that communicates wirelessly to a torque controller. It is programmable. And it not only can measure the fact that you reached a certain torque, but it can even enforce a certain torque profile. So it'll drive the nut down. As the nut starts to hit a surface, it'll start to measure how many degrees of angle the nut turns before it reaches the target torque. And it can verify that you even have a washer underneath that nut. But that is a type of technology that's common in industry, and there's a dozen different brands that we interface with. They all have their own protocols that we talk to them over. And we implement those protocols and we work with those torque tools. So the short answer is a smart torque tool. It figures out that it's tightened correctly, and we communicate back and forth over Ethernet protocols to it. With the shot glass example, Ryan mentioned there are some Bluetooth pour gauges that you can have, but generally speaking, we would just error-proof the fact that you took it to that glass, you didn't forget to pour something into the glass, and that would be enough for most of our customers. If you really cared about exactly how much fluid went into that glass, we could do a whole bunch of different ways to verify, did the fluid level go up by a certain amount, put capacitive sensors or laser sensors or something like that to measure the fluid level. Or we would have, maybe a camera looking sideways at the glass to see the fluid in the clear glass from the side view. And we have algorithms that's in our platform, and you can use them. If you have a clear water glass or water bottle, you can use our system here and have a camera and look for the edge of the water and look for it in a certain range. If it's in that range, that's good. It'll be green. It'll move forward. If it's outside the range, too high, maybe it turns red. But you have control over that experience. But it's usually a mix of sensors and inputs and cameras and things, depending on what's appropriate. We always caution our customers. You don't want to error-proof too much and try to measure everything and prove everything, because you're going to spend a lot more money and spend a lot more time, and it's going to break more often.
Just one quick question. So the shot table, how many projector and sensors to make that happen? I'm just curious.
For which one?
The shot table, the demo of the shot table.
There's just one projector overhead, and then the TV screen or monitor underneath with some glass. So 2 displays. 2 displays, 1 vision camera. And something that wasn't shown in that video was that was at the show. So that was a video in our office, but when we actually went to the show, we had another projector that was shining behind the person making the drinks where all the bottles were. Yeah. And so we were able to show you, hey, you know, it's not top shelf. This person's getting, you know, New Amsterdam instead of Grey Goose or something. And so we'll know when the person grabs the right bottle, and that'll be our cue to then go on to the next step and show you what drinks get that specific ingredient. So in the video you saw, just 2 displays. In the actual deployment, it was I think 3 displays, 1 underneath, 1 on top, and then 1 shooting behind.
I just want to say it's genius because it's like cheap, fast, and you get things right accurately. So I do see a lot of like potential in this use.
Yeah, it's very important to be fast. So we have a policy, you know, our logic and everything needs to happen within 1/10 of a second to be responsive. If you're less than 1/10 of a second, people generally think it's immediate, you know. With vision, it sometimes takes longer, especially AI vision. So in that situation, we usually have a requirement for less than ½ a second for the vision to verify something. If you're spending longer than that, you need to work harder, maybe get more lights or something, and get a faster computer or whatever, so that you're not waiting for the system to see it.
Yeah. Any other questions? Yes?
So your system, the projector is additive light, right? Like in terms of mixing colors and things like that?
Mm-hmm. Yeah.
Is it powerful enough to show like subtleties in colors, or is it, there's a few colors that it shows really well, like red, green, blue, but very like strongest version of those?
That's a great question. I have on our online documentation, I have a page that kind of describes that a little bit. So it's a red, green, blue video projector, just like any other video projector. We use different brands. So there is a red, a green, and a blue component. So number one, if you turn all 3 components all the way up, that's white. That's going to be the brightest, you know, amount of light. So generally, we recommend using a white light. So you see a lot of those graphics, we do that. Sometimes if you have, for example, a shiny metal object, and you're in a room like this with a lot of white lights in the ceiling, you're going to see the glare from those white lights on your shiny metal object. So projecting white kind of blends in a bit, even if it's the brightest. So in that situation, using green actually usually shows up better. So there's more contrast, you know? And green, out of those 3 color components you have as options, green is the brightest by far. And you'll notice if you do a pure blue or a pure red, it's actually quite dim. And there's a reason for that, the way our eyes are sensitive to different wavelengths. So in terms of the hierarchy of brightness, white is the brightest, green is the brightest primary color. Brightest secondary colors are yellow and cyan. So yellow is green and red, cyan is green and blue. And then it goes down from there. And you can see a mapping of exactly what percentage brightness they are of each other. But it's very different compared to a monitor. So for example, if you have a white light and you get a brighter projector, it'll be more white. Your other projector will technically be a gray, you know, because gray is just a less bright white. And you don't have the cues you get on a regular display monitor to kind of see that difference. You just see a dimmer white. So psychologically, it's a little different, you know, when you're projecting.
So besides the intensity of the color, would it be able to determine something like a lime green versus like a chartreuse? I don't know if you like can picture those colors, but like they're very subtle differences.
Right, yeah, so we have vision algorithms that have hue filters and things like that that can detect color. And we do not recommend using lime greens or pine greens and chartreuses and things because a significant proportion of people are colorblind. So when we use green, we use the pure green, like the green component color is all the way up and the reds and blues are all the way down, which is not enough for some people, but for most people with red-green color blindness, they can at least tell there's a difference going on, you know? It looks different than it would otherwise look. So yeah, the pure red, the pure green is the biggest possible chance for people to see the difference. But we never look at color alone. Like we always have what we call double coding, where you have the color and the shape, or color and text, or color and location, so that you have a little bit of extra cue for even colorblind people. So although color is a very useful tool for people who can see color to give them more information and make things more intuitive, you have to be able to run, assuming somebody doesn't see color.
Any other questions? We got hackers here, so I want to know. Yes, Andy.
It's okay if you can't answer this question if you're already going to sprouts. But I was just curious, how much does it take to manufacture sprouts?
Oh, that's a good question. So we actually don't manufacture the sprouts. So HP was manufacturing them some years ago, originally trying to use them for structured light scanning and some design work. So you take your shoe, you put it under the projector, it would scan it and get a 3D model. You then edit it, augment it, but did not get a lot of traction there. Also, there was some ploy with